Hello and welcome to today's webinar, Integrating Mainframe Data and Processes with Distributed Systems and the Cloud, brought to you by Luminex Software. My name is Casey Smith, and on behalf of Share Headquarters, I would like to thank you for joining us today. Share is pleased to continue our webinar programming with this informative and educational event. Today's presenters are Art Tolsma and Scott Spiro. Arthur Tolsma co-founded Luminex in 1994 and serves as its CEO. Luminex has grown profitably, delivering on a vision for modern mainframe data management. He is a frequent industry speaker and well known in the mainframe and storage communities. Scott Spiro is a senior partner development manager for worldwide mainframe and data center transformation with 6 years of experience driving enterprise credibility at Microsoft and 20 years experience on the IBM mainframes and distributed environments. We encourage you to submit questions throughout the event via the Q&A box on your webinar toolbar. These will be addressed at the end of the presentation. I would like to now turn the webinar over to today's presenter. Please go ahead, Art.
Thank you, Casey. This is Art Tolsma, CEO at Luminex, and it's a privilege for me to have this chance to speak with you today. I appreciate you taking your valuable time. Those of you that are live on the webinar, also for those that may be listening on a recorded version after the fact. Appreciate this opportunity. We're going to go ahead and talk through what we're going to, the agenda for the next 45 minutes to an hour. Understand that in this age of multitasking, I'll call it, not everybody's paying attention the entire time, and so we're going to be pretty clear and upfront about what we're going to talk about, and then we're going to spend the next amount of time to go through and try to prove and make some of these points a little bit more compelling. So for those of you who want to make sure you have all of the right answers up front, we're going to go ahead and do that. So the discussion is to talk about how the mainframe is valuable and core into the enterprise IT, and in order to maximize that value, it's important to have an integrated mainframe instead of having an enterprise IT infrastructure with various silos of IT. Some of the practical approaches to actually making that happen, to implementing an integrated mainframe, is to have the right data in the right place at the right time. FICON is a mainframe channel I/O that helps make data movement fast, secure, and cost-effective. And what those of us in the mainframe industry have forgotten for the last 15 or 20 years is that mainframe channels were designed specifically for data movement, and it's a core native solution that takes away barriers of moving data between mainframes and other environments. So Luminex is credible with the FICON channel technologies. We're an industry leader. We've been developing and delivering mainframe data transfer, mainframe channel products for decades, back with Bus and Tag, with ESCON, and certainly now with FICON data management, data storage, data movement products. And we'll jump a little bit into that. We're going to talk about the Luminex MDI solutions. MDI is a product line. It's a simple acronym for mainframe data integration, and we're going to get into some of the nuts and bolts of what the products are, what the technologies are, how they can be helpful. Mostly talk about what's available today, but we are going to have a few teasers on some of the exciting new things that we're going to be able to help with tomorrow. We're going to finish by having Scott talk about Microsoft Azure, and I'm enthusiastic about having Scott join. He has a mainframe background. He understands mainframes and enterprise IT, and in IT modernization and in agile enterprise IT, Azure is often a natural endpoint where customers have a chance to move forward leveraging the skills and technologies available with Azure. And so As the title says, integrating mainframe data and processes with distributed systems in the cloud. I think we'll have a pretty, not only compelling overview on why that makes sense, but also how to do it. So when we talk about the integrated mainframe, it's no longer just a buzzword, but in reality, it's a stated goal of mainframe data centers. It's something that is either in progress, or often it's an active reality in the mainframe data centers and enterprise IT today. When I said I was going to go through and prove all of these items, I might have lied just a little bit. Proving that the mainframe is valuable and that integrating it is even more valuable is a little bit broader of a topic than what we're going to have a chance to cover today. But there are great resources across the industry. CA and IDC had a report about the connected mainframe, the recent report from BMC. CompuWare has a vision of two-platform IT that they've presented that talks about enterprise IT being either on the mainframe or out in the cloud, and it's a pretty compelling vision. So I would encourage those of you who have some additional interest just to see how embedded and valuable the mainframe is, not only today but in the future. That would be great. So when we have a chance to talk about why the integrated mainframe, essentially it's to do more for less. It's a little bit of a fit-for-purpose IT, where not every platform is, each platform has its own advantages, and you have a chance to do what's best on that platform. And so at the recent Share conference in St. Louis, there was a nice keynote about yes and that the mainframe community needs to start embracing a yes and mentality, where you can embrace the emerging workforce and new technologies. One of the quotes that I wrote down, I hope I didn't write it wrongly, one of the industry leaders in the mainframe community made the statement about the mainframe that the idea of opening up and cross-enterprise innovation is transformational, and it makes the mainframe more nimble, consumable, and valuable. And I think that's a great quote because it just signifies that, you know, those in leadership and those with most at stake see the future of the mainframe as being an integrated mainframe. So quick background on Luminex. I highlighted it just a little bit before. We've been delivering mainframe virtual tape solutions, mainframe data movement solutions for decades. We're known for our virtual tape products. We've been supporting mission-critical data operations in small and large data centers across 6 continents every single day. We are a mainframe-focused company. This is what we know and what we do best. The little box in green actually has our mission statement. And what I want to pull out of that mission statement is the phrase that says leveraging corporate data assets. And that's what we're going to spend the rest of our time talking about, is how best to leverage corporate data assets. And the point there is to do more for less, more often. So when we look at that, it's all about the data. You create data, you want to process it, create some new data, you want to analyze it, create some new insights. You want to report on the data, maybe make some business decisions based on those reports. Sometimes you have to move data around. Where it starts and where it ends isn't always the same place. Of course, you've got to protect the data, back up, encrypt, secure, archive. There's lots of things that you do with data. And as we look at the enterprise IT, there's not a single platform that's best for all of the activities. And so there are cases, we've seen cases where it can be even up to orders of magnitude where it's faster and cheaper to do complex analytics off the mainframe. If there are environments where you want to do reports that include both mainframe data and non-mainframe data, it's likely simpler to do that using the tools off the mainframe than to move all the other data to the mainframe. And so there's a lot of opportunity where to run your business and leverage the data, you have to be able to get the data in the right place at the right time. And again, what we've forgotten is that FICON is a technology specifically designed for this purpose. So, of course, everybody understands they use FICON as a mainframe channel I/O. It's a fast data movement for their operational data, for their databases. It's what's used for the virtual tape, physical tape systems that are out there. Again, what the industry has sort of forgotten, that it's also designed to support file transfers. For those who want to recall a quick history, back when we delivered bus and tag solutions and SCON solutions, file transfer was one of the primary reasons to use those mainframe channels. And as Ethernet got fast, before SCON got fast, customers and the industry moved towards using Ethernet and TCP/IP. It never quite got back to the roots of leveraging mainframe channels for data I/O. So we have that history and that institutional knowledge to understand where that can be helpful. So I'm going to take a little bit of a step back and talk about the virtual tape routes that everybody's a little bit more familiar with. So virtual tape system, you've got a controller, it's connected with physical cables over FICON, and you've got a data storage system. And so over time, all sorts of things to help manage that data. You can encrypt the data, you replicate it, you can send it to the cloud, you can make DR testing easier for point-in-time snapshots and disaster recovering. And fundamentally, what we've been able to do with our virtual tape products is that you move data over FICON, you put it somewhere, and then you do things to it. And all of this is to support the protect section of what do you want to do with your data. You want to protect it. These are the things you do. This is what our customers around the world do every single day. So expanding that into a data movement scenario, instead of using backup software in the mainframe, we've created some data integration control software. We've created a bi-directional communication link over FICON, leveraging the FICON I/O for data movement. And so our MDI products, our mainframe data integration products, leverage the same physical infrastructure as our standard virtual tape system. But what we've done is created a control platform on the mainframe to say, here's the data I want to move and do something with, and here's the instructions for what you should do. And there's a whole world of things that you can start to do with the data. So we've got software running on our MDI platform with communication saying, basically performing those functions, and moving to Hadoop or out into the network or cloud, or lots of things you can start to do with the data. Mechanisms for translation, conversion. It starts to be a pretty unlimited opportunity to move large files, move lots of data. The mainframe has a mainframe-centric approach to getting feedback from the MDI platform, that server, to understand whether the process was successful. And so we've built on that tried and true proven core virtual tape and created an MDI data movement platform. I'm going to talk a little bit more about why that's useful. Just jump through quickly. By leveraging FICON and the way we've designed this product line, it's secure, fast, cost-effective, efficient, and essentially when you remove barriers for data sharing, you create opportunity for data integration. And we're going to go through that a little bit. Last year in the summer, Luminex did a customer survey and asking customers, how do you move data today? What technologies do you use? And so there's a pretty wide variety of technologies. The common secure FTP, SFTP, and FTPS are out there. The commercial products, Connect Direct, and those who like the street cred continue to call it NDM, IBM MQ. But of course, over half of the customers self-reported that they use FTP today. Now, FTP is generally considered, frankly, a bad idea. It's easy and cheap, but it's a bad idea for a lot of different reasons, and a lot of customers have said that they're trying to get away from that, which is why they've moved to these other solutions. The interesting thing, in addition, is we talk to customers. So this was a self-reported survey, and so we would talk to a customer, and they said, "Well, I'm using Connect Direct. I've got a managed file transfer product, so I don't have any issues." And so we would do a deep dive and look at their SMF analysis and say, you know, you're right. You've got 500 important jobs a week that are using Connect Direct and moving data back and forth. But did you know you've got 5,000 jobs a week that are running FTP, unsecure, ad hoc, things that were not mainframe managed within the mainframe discipline? And so our experience is that this self-reported number is well underreported, because what management knows and what actually happens aren't necessarily the same thing as it goes to data movement, because the pressures to access and move data between the environments are just continue to increase as enterprise IT looks to implement that integrated mainframe. And so FICON's a better approach. Talked about it: fast, secure, cost-effective. And so we'll go through a few extra reasons to kind of make that more compelling. So if any of you have heard Mark Wilson talk recently, he's been at Share for the last couple of years giving presentations on mainframe security, a great speaker. He and his North American partner, Chad Rickensrud, great guy. He's been bringing the concepts of mainframe security to other conferences like DEF CON and Black Hat. And I'd highly recommend anybody to go listen and learn something. You may want to wait until after Halloween, because most people come out of their presentations with their eyes wide open and pretty darn scared. Because the discussions of mainframe security are a lot more interesting than most people in the mainframe community realize. And, you know, apparently when everybody's running Java with open IP ports, your mainframe may be less secure than you thought. What Mark has said is, FICON's a secure data path. TCP/IP is not necessarily secure, and you can eliminate a whole lot of risk if you can leverage FICON for moving data around. And so there are a lot of areas where that's just a simply compelling way to secure your mainframe data and secure your mainframe environment. And it's increasingly becoming more recognized as an issue that we have to address in the community. So FICON is fast. A simple little picture. This is actual customer data, moving data from the mainframe to another source on their network. It's, you know, you can move 10 gigabytes in a couple minutes, or it could take you know, 45 minutes, take a long time. FICON as a data channel I/O, there's no issues with moving large files. You can move lots of things at once. Once you start looking at moving data off your internal network, the issues become even more severe. And so from the more data you need to move, the more valuable FICON becomes, just from the fact of getting things done. We did have a quick anecdote. A customer recently moved a 10 gigabyte file out to the Microsoft Azure data lake, and it was in the Hadoop data lake within probably about 20 minutes, and doing something like that was completely impossible to do prior to using the MDI products. And so it really gets into the do more opportunities when you can use a FICON-based solution. Okay. So a third core reason if FICON is better is that it's cheaper. So if you're just using unsecure FTP, FICON uses about a third fewer CPUs, about a third of the CPUs of FTP. FICON is a specifically designed mainframe channel where the data movement processing is off the general CPU, and it's designed to do it very cost effectively and very cheaply. When we've done benchmarking against secure FTP, we found that the FICON channel used about 1/30, 3% of the CPU use of the SFTP. And so we commonly see customers that are using 10 to 15% of their mainframe CPU is spent on data movement with TCP/IP. And when you think about 10 to 15%, you think about how much it costs to run your mainframe. You think about the bills that you pay at the end of the month based on your CPU usage and who gets all that money. 10 to 15% can be a pretty significant amount, and maybe there's some juggling to move the data around, but that's a lot of juggling that could make your operations more efficient if you didn't have to do that juggling. So saving CPU cost is also a pretty significant, compelling advantages of leveraging FICON versus the other TCP/IP mechanisms. So in kind of an overview, our MDI products are truly fundamentally better by leveraging FICON as the network. And we didn't stop there from an advantage standpoint. Being mainframe folks, we took a very mainframe-centric approach to this product line. We didn't like the idea of people running data with a Hadoop cluster, and they want to get mainframe data, and they'll just issue a command with this tool called Scoop. It'll go to mainframe, and it'll FTP the data over, and people are getting the data the way they want it, but it's not the way the mainframe people want it. It's not necessarily with the mainframe discipline. So we like the mainframe control. We like the bi-directional communication. And we have a chance to leverage a unique control path leveraging FICON and the tape APIs. We certainly have a very enterprise-proven product, and for those that are currently Luminex virtual tape customers, it is literally the exact same physical infrastructure. And so the MDI product is a software product. It combines mainframe software and additional software on the MDI server, but it's by leveraging the exact same physical infrastructure. We've got the additional reliability quality. We've got and we can leverage the two platforms together, and potentially even reduce some of the data movement that's necessary. So I've been talking fairly quickly here. I'm going to go through fairly briefly. We can have entire presentations on each of the Luminex products that are presented here. But what we've done with the MDI platform is productize some very specific use cases that our customers have asked us about. And so the mainframe software is integrated with the security framework, RECF, top secret, what have you, to make sure from a mainframe-centric design that authorized people are doing authorized things. So top to bottom, we can a mainframe-centric approach to move data fast over FICON and give it a command to put it into a Hadoop cluster. And we call that product our big data transfer product, and it leverages the web HDFS protocols to move data over IP securely into a Hadoop data cluster. We can do some pre-processing, conversion, optional EBCDIC to ASCII, and other data conversions prior to moving that data, and it simplifies the process of getting data back into some of the data lakes and platforms you want to manage and analyze and process that data. The second one is XPDS. It's an acronym for cross-platform data sharing. Essentially, that provides a mechanism to move data into another part of your network. Leveraging the NFS protocol, it moves data to another processing platform. So the mainframe control software can do a push or pull, or as they say, a put or a get. And can send data and it can receive data. And so we found one of the more suitable use cases for this product, the XPDS product, is to leverage a MDI as a co-processing platform, or to implement the co-processing strategy, so that for those environments where you want to use tools not on the mainframe, for those environments where it's faster or cheaper to use non-mainframe software and tools. You can move the data, get it to where it's easy to process it, and read that data back. And so we've seen a lot of different customer examples and use cases where the XPDS product is a very simple, easy, functional co-processing platform, even for mainframe-centric workloads. The MDI secure transfer product essentially is it's a managed file transfer product, MFT, and it consolidates and simplifies the other data transfer mechanisms currently in use, FTPS, SFTP, Connect Direct, and other sort of commercial managed file transfer products. And so by its nature, you're moving the IP connection to the endpoints over to the MDI platform instead of to the mainframe. And so you can keep the mainframe secure so you can get the data off the mainframe fast and securely. You don't have to deal with digital certificates and all of the other endpoint complications you have, and allow the MDI platform then to have these secure connections of getting that data to its appropriate endpoints. Of course, with the bi-directional communication, the mainframe can wait for job completes and things of that nature. It just doesn't have to be doing the work the whole time. And so it's a fantastic managed file transfer product. And what we call the SLP, it's an acronym for the SAS Language Processor, and it's a very specialized use case as a co-processing platform. And so what we've heard from a lot of customers is that a lot of resources can be taken with capacity planning. MXG is a widely used tool that runs along with the SAS language. And so we've developed some end-to-end solutions that allow moving the SMF data, moving the SAS jobs, and letting MXG SAS language run on Linux, but still from a mainframe-managed, mainframe-directed approach with results sending back to the mainframe. And so it allows capacity planning to be done in a more real-time ad hoc fashion without any MSUs on the mainframe. And so it's a pretty fascinating product. We've been able to prove out some of the high-value use cases of the MDI as a co-processing platform. If you've seen some of these products, there's others coming around. I've got the end more little bullet there. What these have in common is that they are batch-centric, and so these are scheduled, these are ad hoc, these are JCL-driven activities, and these are each extremely useful on their own. But there's a lot of other use cases for integrating mainframe data to the other platforms, and if we categorize batch and then real-time and near real-time, I think we can talk about real-time as from a sub-second, millisecond. It's functionally live data in two different locations. And then the near real-time would be from seconds to maybe minutes to have the mainframe data that's created live and available for use off of the mainframe. And so the teasers here, I don't have product names, I don't have dates, because that would start to sound a little bit like a product launch, and I don't want to go down that road today. But we have a whole family of products that are in the near real-time category, where data that's created on the mainframe is transferred live without human intervention in near real time down the FICON channel and piped into Kafka, as well as potentially some other direct endpoints. And from a Kafka perspective, widely used as not just a messaging bus, but it's a near-term repository for a world of applications that can use that real-time data in business analytics and running the operations. And so we're pretty excited about what's coming around the corner. And we'll say those of you as customers that see some use cases or real-time needs in your own environment, please feel free to contact us specifically about that, because we'd like to we'd like to work with you from an early adopter perspective on how to get near real-time data into your valuable endpoints and leveraging Kafka to do that. So that's another exciting MDI product that's coming around the corner. So the last slide for me to talk about is a little bit more into the couple of the use cases. From a customer perspective, I guess starting at the bottom, we've done some pretty large-scale work with the SAS language processing and capacity planning, and so it's pretty exciting some of the compelling values that we can bring in just the scale of capability that's available for moving that capacity planning off host. We have banks essentially leveraging the secure transfer product to be their primary production managed file transfer product. Because it's easy, they can start to eliminate some of the ad hoc FTP. They can simplify, they can do more because it's not complicated to set up an SFTP. And they don't have some of the restrictions for large files and concurrency and things of that nature from their existing managed file transfer product. And so there's a lot of values that we've been able to see. Simple things like language translation when you're looking in international marketplaces that we've been able to uniquely provide. So we have customers in financial industry using our XPDS product. Mainframe-centric processing found it easier, it's faster on the wall clock, saves a ton of CPU. Move that data off host, leverage Apache, Ignite, some of their existing technologies that they're comfortable with on the distributed environments, process that data, get the results back to the mainframe, and keep these mainframe operations moving. Again, you save wall clock space, save a ton of CPU. When that happens, you can start to do more with your data. And so it's a pretty exciting to see some of those coprocessor use cases with the XPDS. And the conclusion from my part of the presentation, we have customers and insurance provider talked about here quickly, moving vSAM data in nightly batch process. They can move that to the Azure Data Lake, move it directly, high speed, off the mainframe, doesn't take any MIPS on the mainframe to get that data moved off, and then sent securely and directly placed into the web via web HDFS into the data lakes on Azure. And from there, they can leverage their in-house, their software for risk analysis. They can integrate it with their other enterprise data and make better business decisions by having those capabilities. And so, as I mentioned at the beginning, Azure Data Lake is a natural and valuable endpoint for IT modernization and what an integrated mainframe can look like. And so with that example, I'd like to hand it over to Scott Spiro and give him a chance to talk a little bit about the Azure Data Lake and some of the advantages and capabilities that functionally now are available for active use with mainframe-generated data.
Art, thank you very much. That was a great job and great transition. And thank you for joining the webinar today. Art made some great points around the integrated mainframe, and that's what we're seeing at Microsoft is that you're looking at the Fortune 500 who predominantly have mainframes in their operations. They need to free that data. And really, this is a transformational period, as Art said, where you're exposing this data and as well as combining it with additional data sources. And it's this combination, this joining of data from disparate sources and being able to provide analytics against it that's really providing the power to the organizations. So really what we at Microsoft are doing is with the mainframes, we're exploring what's called the art of the possible. And with Azure Data Lake, what we have is the ability to take this data and pull it out of the silo of where it's been in the past. And using the tools of Luminex, you have that capability to bring it into Hadoop clusters, to bring it into Kafka. And so what we've seen is this data is now free from the silos. It's been difficult in the past to analyze this data and compare it against other data sources, but it's becoming easier today. Really, it's all around analytics, being able to run machine learning algorithms against it, write R routines against it, being able to take this data and take disparate data such as IoT data from sensors and marry that to the data that you have. Being able to scale those analytic engines, that data and analytics to what you need. And then, of course, this all has to be encompassed within a secure environment, from data in transit to data at rest. And so really what we're doing at Microsoft is being able to address these challenges with Azure Data Lake and our Azure suite of products. So a data lake uses what's called a bottom-up approach. Top-down is traditionally you define a schema for your data and then import the data using that schema. What a bottoms-up approach means is that you're allowing the data to define the schema, to define the layout. And the data can be from multiple sources. As I mentioned, it could be from IoT sensors. It could be from SAP, your line of business applications, an ERP or a CRM application, your core banking applications. It could be from web analytics, various relational databases that you may be supporting. So all of these different data sources, including your social analytics, your video feeds that you can now perform analysis against and do comparisons against the actual image, the images that you're seeing. What Data Lake does is you're taking this data in. A Data Lake store is traditionally on-prem, and we'll get into this a little bit more. It's a combination of the storage as well as the analytics. But now by moving this up into Azure, we're now able to separate that out and scale in a very efficient manner to be able to hit those performance metrics that you need. And once it's in that store, now you can start taking that data and feeding it to various queries that are out there. Your analytics, your, as I said, ML, feeding it to a data warehouse. As I mentioned, traditionally, your on-prem data lake was within a Hadoop cluster, which combined both the compute and storage. But now, by moving this into the cloud, we've actually separated that. So now you can store the data and then scale your compute clusters appropriately. The same with the storage clusters as well. And this is, as Art mentioned, they have the tools to be able to drop this into Hadoop via the Web HDFS APIs and be able to scale this very efficiently and very cost effectively as well. So there are two ways, there are actually three parts of this. There's the ingress, which is basically being able to consume this data from the various sources. So you're taking this from your SQL, your Azure SQL, your on-prem SQL, your data warehouses, maybe Oracle, Sybase you have, as I mentioned, your line of business applications, and we use what's called Azure Data Factory to process that and bring that into the data lake. You can then also take your storage blobs, bring that in, take your IoT data from the Azure Event Hub, and bring that in using what's called Azure Stream Analytics. So that'll take the input from the Event Hub and bring that into the data lake, as well as various client applications as well. Once it's there, you can then conduct your analysis on it using analytics, various analytics engines, and then take that resulting data and output it, basically back to the same sources that you had before, whether it's a data warehouse, other databases that other line of business applications are using, or feed it right to those applications. So Data Lake is built, as it's been mentioned, as an open standard. It has the ability to integrate with Hortonworks, Cloudera, and others that have read-write access to the Data Lake. It's built from the ground up as a Hadoop file system with support for file and folder objects and operations. Security is built in throughout. It is POSIX compliant enabled. One of the things that Art mentioned was that with their MDI big data transfer application, they can basically take that direct to Hadoop in a very fast and efficient manner. He compared that against Scoop. So one of the things I need to do actually, Art, is update this slide to add your product in here.
Sounds great to me.
As I mentioned, Data Lake has been built from the ground up to be a secure platform. It's directly integrated with Active Directory, both on-prem and in the cloud. Active Directory supports hybrid models, so you can have it one definition, and it can transfer between the cloud and on-prem. Encryption, both in transit and at rest. The durability and availability. Azure by itself is a product whereby you are actually copying the data into 3 different regions, or I'm sorry, 3 copies within a single region for high availability and DR purposes. So Data Lake has been optimized. It's been optimized to scale regardless of the sources that you provide. As I said, multiple input sources for ingress. It's optimized for analytics so that as the data becomes more and more prevalent and you're storing more and more data, your clusters grow to support that. Your analytics engines grow to support that, so they can scale up and they can scale out as well. And then also the high volume it will support. The streaming capability. So I mean, a lot of times you find IoT data. It's very small writes, but it's very fast from multiple sources. So Data Lake supports that. As I mentioned, that's really coming through the Azure Stream Analytics and the Event Hub. So the capabilities of this, it's really provided for across the board within the organization. You know, from an analytics perspective, it supports batch and streaming workloads. It's automatically designed to optimize and also parallelize by analyzing the data as well as the events coming in and the routines that you're coding. As I mentioned, it supports machine learning, Mapper, and others in terms of building those routines. From a developer perspective, various scenarios, we support Visual Studio and PowerShell. And from a cost and efficiency, and I'll give you an example later on in terms of that, but it's extremely efficient. So Microsoft runs on Data Lake. As you can see, the various properties that Microsoft owns from Exchange to Bing to O365, all of the back-end data sits within Data Lake. So we've built it to support it. We drink our own Kool-Aid in this case. We utilize this across the company, and it's for mission-critical applications within the Microsoft organization. 90% and growing Fortune 500 companies use Microsoft Azure. So they're using the public cloud. We also have a Gov cloud. We support that. And then we also have the private cloud as well. So we support, as I said, 90% of the Fortune 500 companies out there. A lot of these you may recognize. And finally, on the Data Lake store, as I've mentioned before, it can store structured, semi-structured, unstructured data. That's what Hadoop does. All of your Hadoop applications, it's built for the enterprise. Security, reliability, resiliency is all built in. and it's designed to meet the performance of big data applications. All right, Art, that's it. Back to you.
Thanks, Scott. And I think we'll probably have a chance to take a couple of questions here.
Yeah, we've had a few questions come in. I'm going to start with the first one. Does MDI require a Luminex virtual tape system, or can it be used alongside of other vendors' virtual tape? And if so, how?
It's a great question. So MDI is an independent product of virtual tape. We have customers that are not Luminex virtual tape customers but are active MDI customers. It, as I mentioned, it shares the same physical infrastructure that's required for the FICON data I/O. But no, the customer does not need to use the Luminex virtual tape in order to use the MDI. There are some infrastructure and operational advantages in using both, and so we'd love to share some of those as well, but they're definitely independent products.
Okay. I have another question. Is it fast to only send data out of mainframe or bring data into mainframe too?
Okay, so that's a great question. So the FICON channels are super fast, and so moving the data either direction is very fast. It's a two-step answer on the bringing data back to the mainframe. So we have an input directory for processing the data coming back to the mainframe. And so the first thing that we do is format that data into a data set in virtual tape format and tell the mainframe to catalog it. Of course, asking permission through RecF, etc. And so the data is available to the mainframe without any mainframe I/O. And then once the data is read and used, it's read over the FICON channel, which is super fast.
All right. Then I have a question maybe you can answer, Scott. I've heard of Azure Data Lake Gen 1 and Gen 2. What is the difference?
Great question. So what that refers to is actually the data lake storage, Gen 1 and Gen 2. And so Gen 1 is formerly known as just Azure Data Lake Store. What that is, it's an Apache Hadoop file system, and it's compatible with HDFS, and it works with the Hadoop ecosystem. So what that means is your existing HD Insight applications or services that use Web HDFS, the API, it can easily integrate with Gen 1. So Gen 1 also exposes the HDFS compatible REST interface for applications. What Gen 1 also provides is unlimited storage. So it's suitable for storing a variety of data for analytics. As I mentioned, everything from data coming off of your line of business applications to IoT sensor data. It doesn't impose limits on account sizes or file sizes, or even the amount of data that can be stored in the data lake. So individual files can range from kilobytes to petabytes in size. So it's a great choice to store pretty much any type of data. Data is stored, as I said, durably by making multiple copies. As I said, it's 3 copies in a region, and there's no limit on the duration of time for which the data can be stored in the data lake. So really, Gen 1 is built for running large-scale analytic systems that require massive throughput to query and analyze large amounts of data. What this does is it spreads parts of a file over a number of individual storage servers, which improves the read throughput when reading the file in parallel for performing data analysis. Now, the difference between Gen 1 and Gen 2, and Gen 2, I should let you know right now, it's in preview mode now, is the addition of a hierarchical namespace for the blob storage service, which organizes objects and files into a hierarchy of directories basically for performant data access. So the hierarchical namespace also enables Gen 2. It supports object store and file system paradigms at the same time. So in the past, so your cloud-based analytics in the past, it had to compromise in the areas of performance, management, and security. And what Gen 2 does is it addresses each of these. And so performance, it's optimized because you don't need to copy or transform data as a prerequisite for analysis. The hierarchical namespace, as I mentioned, it really improves the performance of directory management operations, which improves overall job performance. So what this does is management is easier because now you can organize and manipulate files through directories and subdirectories. And security is enforceable because you can define POSIX permissions, as I said, it supports that, on folders or individual files. What this really means at the end of the day is that cost effectiveness is made possible by Gen 2 because it's built on top of low-cost Azure Blob storage. And what this does is the additional features, it further lowers the total cost of ownership for running big data analytics on Azure.
All right.
I know that was a long answer for a short question. Sorry.
There's another one maybe you could answer. Can you give an example of where Azure Data Lake was used?
Yes, I can. Good question. So there is a U.S.-based airline, JetBlue, and what they do is they utilize web logs from their website. And what this does is it's provided by Adobe to identify issues and trends based on their end users' experience. So these issues, let's see, how do I put this? The issues were routed to various departments within JetBlue to resolve and improve the customer experience when booking flights. So these logs, again, these are from their website. They're processed through their back-end systems, which in the past took several hours to complete. JetBlue wanted to be able to react to these issues and trends in a much more responsive manner to improve customer satisfaction. And so what they did was that they migrated their Omniture logs workloads, again, this was Adobe, from their on-premise Hadoop to Azure HDI. There was a straight migration from on-prem to Azure HDI for one environment. Then they migrated their Omniture log workloads from on-prem Hadoop to Azure Data Lake, and this is to show that the existing processes can be completed using Data Lake. So what happened was, in the past, the previous process was single-threaded, and it was using Hive scripts. By moving to Data Lake, what this does was it gave the analytics the ability to process in parallel multiple input files and consolidate them for polybase processing. They also use polybase. So by doing all of this, they were able to migrate the current processes off Hadoop and APS to Azure Data Lake and Azure SQL Data Warehouse. The processing times improved by a total of 96%. As I mentioned, it was 5 hours, I think. Current process time is now down to 1.5 to 2 hours. I'm sorry. Current process was 1.5 to 2 hours. The new processing time was 5 minutes. So in essence, it 24 times faster.
Great. I have another question. Can you use multiple MDI products using the same server hardware?
I think that one's for me. It's yes. The answer is yes. The FICON infrastructure is the bandwidth is pretty significant, and so being able to leverage the same piece of infrastructure and multiple of the products together absolutely is a good idea. You would have multiple software products on the physical MDI server and essentially leverage the same mainframe-based control software. And so having them work together is part of the design. Certainly having, from a high reliability perspective, if there are multiple nodes, or maybe a node at DR, things of that nature, we can help from an infrastructure perspective, design the best way to implement. But yeah, all the products are fundamentally designed to leverage that same infrastructure.
Okay. And how do you address data security? Do these solutions integrate with SAF?
Yes, both from a mainframe-centric approach of running the tasks. Having the integration with the security framework is very important to making it a mainframe-centered, mainframe-disciplined product. And so we've seen a lot of the more ad hoc approaches not have that capability, and so that part was very important to us. From a distributed system initiated activity, we leverage some unique opportunities with pass ticket and the like to verify that any activities are valid and authorized. So in the MDI processing environment, we also have native and embedded encryption where any temporary files are encrypted prior to any external movement. And so that data security is central to the product and one of the core fundamental reasons for the product.
Okay. We have two more questions. You're saying the NFS is pushing the data. NFS is more sharing than pushing. What am I missing?
Yes, NFS is it's a network file share protocol. And so from a process perspective, essentially, the mainframe is pushing the data. It's initiating a data transfer from its existing DAS to your tape system. It sends it over FICON to the MDI server, and then the MDI moves the data to a shared NFS storage, moves it to an environment that is shared with other applications that know how to use that data. So yeah, the terminology is best. It's a mainframe-initiated data movement, and we leverage the sharing capabilities of NFS.
Then the last question, is there a mainframe running in the back supporting the Azure Data Lake?
No, there is not. This is all built within the Azure cloud.
Great. So that concludes today's webinar. We'd like to thank everyone, especially Art Tolsma and Scott Spiro and the Luminex team for attending the event today. Thank you again for attending today's webinar, and have a great day.